Hey everyone, I'm Will, I'm the TheRandomCoder from TheRandomCoder.com, and today I'm going to be going through this LeetCode example, problem number 9. It's an easy problem. So my previous stream I wrote this solution, which is a string based solution to identifying numbers as being palindromes. So the high level explanation for how it works is you convert x to a string. Sorry, I was just thinking I should probably go over what the problem is. So the problem is to identify palindrome numbers, being a number that is read the same forwards as it reads backwards. So yeah, you can see 121 is a palindrome because if you flip it, it reads the same forwards and back. So to the solution, so we convert it to a string, get the length of the string. Well, we actually get the length, divide by 2, because we only need to consider half of the string to see if it matches with the other half. If it's like a 7 character string, so that's odd, so dividing by 2 would result in a decimal. In that situation, we don't actually need to consider the middle character, because it doesn't have a character to compare it with. It's the center point. So that's why we take the floor. So we round down to an integer. So once we have this value, we iterate over from 0 to 1 less than that value. And because you can access the individual character elements of a string, we can rather easily access each character, so iterating from 0 to say 3, if we use the example of a length of 7, a 7 character length string. We can compare the start of the string with the end of the string, so that would be 7 minus 1 would get the index position of 6, and then minus I would cause the iterator to reduce by 0, 1, then 2, to sequentially move in characters as the loop iterates. So going down to the bottom of this, there's a follow-up question which got me thinking, and I thought it was quite a neat problem to try and solve. Can you do this without converting the integer to a string? And you can, obviously, I guess, because they wouldn't have written that there if it wasn't possible. And I thought that would be a good and interesting exercise to do that today, to see how that would look. So I'm just going to create a copy of this just as a reference point for what we had before. I can't make that smaller. That's okay. We don't need a lot of room. I'll come back to that later anyway, so that's fine. So we can delete all of this. So I think what we can do is follow the rough principle, the same high level idea. We want to compare sequentially the start and end characters, but we're going to have to try and do it mathematically. So the first thing we need then is to get the length of the number. So how can we do that mathematically? So there's a concept in mathematics, so you're probably familiar with raising things to a power. So if you take 10 and raise it to the power of 2, so 10 squared is 100. And each time you increase the value of the power that you're raising 10 to, you basically get an extra 0. So this value gives us an indicator of the length of these items. So 0, you've got, so if you add 1 to the the amount that you've raised 10 to the power of, it gives you the length of the number. So there's actually a mathematical function called taking the logarithm of a number, and it will basically do the opposite. So when you do something to the power of something, so you're doing 10 multiplied by itself twice. So a logarithm essentially does the reverse of that question. So it is, well, how many times would I have to multiply 10 by itself in order to get this value here? And the answer to that question would be 2. So the mathematical function is math.log. In fact, I think it's math.log 10, because you have to specify the base. Oh yeah, I've got it here. So yeah. So taking this as an example, if 100,000 is the input to the log10 function, the result that we get is 5. And yeah, that corresponds with this pattern that we're seeing here. So 0, 0, 0, 4 and 5. So that's really useful, because we can take the logarithm of our number and we can get the number of digits in our number by taking the logarithm of the number and add 1. Just because if we get 1, we've always got a length of 1, but the base 10 logarithm of 1 is 0. So we need to add 1. And additionally, if we have numbers that are between these nice round numbers, we'll get a decimal. So here, if we had 99999, so 5 nines, the value we get back wouldn't be 5, it would be 4.99 something. So we need to round down. So that's what we want. You can use math.floor to take the integer component of that calculation. So that actually now gives us the number of digits in the number we have. Now I've just remembered the existence of negative numbers, and that's a bit of a problem, because I've got a feeling that's not a number. If we inspect, I can go to console, do math.log 10 minus 1, not a number. And also I think we'll have a problem with 0, yeah. So given that is the case, we can add just some special cases here. If x is less than 0, return false, because we know if it's negative, it's going to have this negative number sign in front of it, and therefore it won't be a palindrome, because you'll never have a negative on the other side. So that's always false. Equally, if x is equal to 0 exactly, now we don't want it executing this code because this is going to be an error. So let's just return true here. Have a special case for 0, and that covers the possible errors that we might get when executing this. So that's quite convenient. Okay, next. What do we want to do next? So I suppose this text length that I calculated before, with the string version, I only actually got half of the length, because we only need to compare when iterating. We only need to iterate half the length of the string. So I think we ought to have pretty much the exact same code. Let's go iterate digits, and we will change that there. So if we had 7 digits, we only want to iterate 3 times, because we compare the first with the last, the second with the second from last, and the third with the third from last, and we can ignore the center, because when it's reversed, you don't need to compare it with anything. So 3 and 3. So that's good. So now I think we can probably reuse this as well. We can go iterate digits, swap that for text length, and this is where it's going to get spicy. Now we need to figure out how to actually access the individual digits, and to do that mathematically. So the idea, so this should be reasonably familiar for anyone that's done a reasonable amount of programming. The concept of a modulo. So even in mathematics, actually, you'd probably be aware of the modulo operator. So if we do 1, 2, 3, 4, 3, 2, 1 mod 10, what this is essentially doing is asking the question, if I divide by 10, if I divide this number by 10, what is my remainder? So taking this example, the remainder would be 1, because you know, if it ends in 0, that's an even division. You've got no remainders, but if you've got 1, you've got 1 remainder. And that's true all the way up to 9. So if you divided by 10 here, you'd have a remainder of 9. And once you flip around to the next 10, you'd be back to 0 again. So that's a convenient way of getting the last character. So we can write that. Let's do it will be x, sorry, let's name it, last digit equals x mod 10. But this only works for the last digit. What we actually want is to work our way up the number as we iterate over these in this loop. We need to somehow work our way up through the number as we go. So here's an idea. So if we were to try and get this number, we could first divide by 10, and that would give us a decimal point there, and we'd have this value because we've taken the original number, divided it by 10, and we've got this these digits at the end that we can probably trim off with the floor function. So I think that's a good way of doing it. So instead of doing this, we can do x, just put it in brackets, divided by 10, but it's not going to be 10. It's going to increase for each iteration. So on the first iteration, we want it to be, we'll divide by 1, let's say, because that's that just results in the same number. Then we want to divide by 10 to get to this number. Then we want to divide by 100 to get this number. So what we can do is do math.pow to raise 10 to a power. And if we raise it to the power of I, 10 to the power of 0 is 1, 10 to the power of 1 is 10, and 10 to the power of 2 is 100. So this actually does exactly what we want. So that seems to work. Then what we can do is do math.floor to remove the decimal component immediately prior to doing the modulo calculation, which will give us the actual digit that we're interested in, or in the case of the second iteration, this one. So that's good. I think that's a solution for getting the last digit. Now we also need to get the first digit. So how do we do that? Now this, as a concept, works well, I think. All we need to do though is modify it to get us the the value from the other side. So we need to start off with a divisor of 1,000,000, I suppose, initially, then 100,000, and then 10,000. So it's the same concept as what we're doing, but instead of increasing, we want to decrease. And we also need to offset the value of I relative to the size of the initial value. So the number of digits, which was 7, using this as an example. For the first digit, this 1, we would have to take digits minus 1 minus I think. So digits would be 7, minus 1 would be 6, minus I, which is 0, is still 6. Therefore 10 to the power of 6 is this. You can see that if we divide this by this, the same length, we would end up with this. Therefore, if we strip off the decimal component, we end up with the value of 1, which is what we were looking for. Now on the next iteration, I will be increased by 1, so we will deduct an additional 1. Therefore we'll end up with this value. This number divided by this value equals 12 point whatever. If you get rid of that, take the modulo of the remaining number, and you get 2. So I think this is correct. The final thing to do is to check the values and say if last digit is not equal to first digit, then return false, because we know if any digit doesn't match, it's not a palindrome. Alternatively, if all of them match and we get to the end of our loop, we know it is in fact a palindrome. So, oops. I think that's the solution. So we can run our code just to test it and see how it goes. Okay, and great, it seems to have worked. So we'll submit the answer to see it ran against a more thorough suite of test cases, and it appears to have worked, which is great. Yeah, and the performance is pretty reasonable, I think. I'll just get rid of that. I don't know if that affects performance, it shouldn't do, but performance has dropped somehow. I've got a feeling this performance tester is a bit flaky, but yeah, it's giving me wildly different answers. But there we go, that's the solution. So I'm quite pleased with that. That's a mathematical only implementation, that's a bit better, of calculating a palindrome number. So yeah, my name's Will, I'm TheRandomCoder, so you can subscribe to me or visit my website and subscribe on my website if you like, TheRandomCoder.com, and yeah, I'll be doing a variety of different tips and all sorts of random stuff. So yeah, that's it for today. Thank you very much.